Hi, my name is Nicholas Arcolano, and I'm the head of research at Jellyfish. Here at Jellyfish, we provide an engineering intelligence platform that gives software teams observability into how they're adopting and succeeding with AI tools across the software development lifecycle. I'm here to speak with you about how we go beyond coding metrics and what it looks like scaling AI for real business outcomes. So let's dig in. We're going to talk about AI transformation, specifically what we can learn from real world data about what's happening out in the wild and what you should expect in your own organization. A lot of AI native companies have been founded in the last year. There's more being founded every day. And there are many more existing companies, though. They're trying to transform themselves into being AI native. I've talked to folks from many of these companies. They all have the same big questions. They want to know things like what does good adoption look like? Um, what do productivity gains look like as you adopt AI coding tools and agents? What should you expect as you transform? What are some side effects of these transformations? What other things are going to happen as you change the way that you work? And most importantly, if AI transformation isn't working out, if it's not delivering as advertised, what's going on and what can you do about it? Here at Jellyfish, we believe that the best way to get answers is with data. So, in the next 15 to 20 minutes, I'm going to give you some data backed insights from some studies that we've done to help you tackle these big questions. Before we dive in, though, I just wanted to take a moment to plug our Jellyfish AI Engineering Trends site. If you find the data that we talk about here interesting, this is a resource that you can go to dig in deeper to find updated information about how all these things are changing. Check out new analyses. We're going to keep updating this with new insights and updated results. So if you find things here valuable, this is a place that you can go. All right. About the data, this is going to underpin the rest of the stuff in this talk. At Jellyfish, we provide analytics and insights for software engineering leaders. To do this, we combine multiple different sources of information together. The first one, obviously, we're going to be talking about AI coding tools, things like Copilot, Cursor, and Claude Code. We're pulling in behavioral data of how engineers are using these tools day to day. There's also autonomous agents, things like codecs that are running off on their own, PR review bots, agents that you're introducing into your tool stack. We're pulling data from these as well. And then we're taking all of these AI technology signals and we're combining this data with things from source control platforms. So things like GitHub, that let you understand about the actual code base, what code is being written, what code is being shipped. We also pull in data from task management platforms, things like Linear, Jira. This tells you about, how teams are structured, what the actual goal of work is that's being done, what's a bug, things like that. So for the rest of this talk, we're going to be looking at findings from a pretty large data set. We're talking about 20 million pull requests worth of data. So this represents about 200,000 developers from around about 1,000 companies. All right, let's dig in. Question one: adoption. What does good adoption look like? Well, let's start with an easy one: weekly active users. This is one of the most basic metrics, and we're just measuring to what extent folks have been successful just rolling out AI tools to their org, getting people to adopt them in any way. Here we're showing what the median WAU as a fraction of total engineers at the company looks like over time, across a set of companies. So you can see the black line there is the median. You can also see the 10th, 25th, 75th, 90th percentiles. So you can see across the entire distribution, adoption's been growing steadily over the past year. And now we're at a point where the median company, the black line, has about 63% of its engineers are using uh, AI coding tools on a weekly basis. Now, a more interesting metric is, I think, to look at frequent AI users. Uh, what we're defining here as frequent is engineers that are using AI consistently 3 or more days a week. Maybe still a low bar, but represents, a dedicated habit of using these tools regularly. So it's important to look at these kinds of metrics because you want to understand that people are establishing a habit of these tools, folding them into their workflow. This is going to be a better measure of adoption and something that we find is more predictive of outcomes. So what you're looking at here is a stacked bar chart where, now we've put the companies into different cohorts. The purple representing companies that have 50% or more of their engineers using AI coding tools frequently, 25 to 50, 10 to 25, and then the gray is less than 10% of engineers. So you can see here looking at the purple bar, we're at a point now as of January 2026 where more than half of companies have more than half of their engineers using these tools frequently. So, that's quite a bit of growth you can see in this chart. Now, if you're at a company in that purple cohort, maybe you're like us at Jellyfish, you're way above 50%. You've got everybody on your team using these tools, synchronous, asynchronous agents, multiple tools in parallel. So maybe it seems crazy to you that not everybody is operating at that level. But the reality is that many teams still face real barriers, technical, organizational, privacy and security barriers, cultural barriers to adopting these tools more completely. So, for big orgs, high compliance situations, rollout can be challenging, and we're seeing that in the data. This brings me to my final point on adoption. Let's talk about autonomous coding agents. The results we've talked about so far, they're from interactive coding tools. So Copilot, Cursor, Claude Code, things like that. We know that these tools all have an interactive mode. They will write massive amounts of code for you. Not just autocomplete. But what about fully autonomous agents? Things like Codex, things where you give it a spec, you give it a prompt, it goes off on its own. It does all of the work. A human might be approving the work, but an agent does everything up until that point. So if you'd asked me last year, how common this is, you might hear a lot about it on Twitter/X. About the way that people are using these agents, in the Silicon Valley arena. But out in the wild, I would have told you that was less than 1% of what people were doing with AI coding tools. But we've seen huge growth here and rapid acceleration. So what we're looking at now, this chart is percent of PRs by company that have been completed by an autonomous agent. So an agent's done the coding totally by itself, based on a spec or a prompt. Open up the PR. A person might have and most likely approved it, but an agent did all the work. So the black line, that's the median again. We're still talking about, basically nothing through most of last year, and now around 1% of pull requests being completed by autonomous agents. What's really interesting is those upper percentile bands. So the P75, the P90, you can see at those tails of the distribution, like the 90th percentile, top adopters here, this is exponential growth. They've approached 10% of their PRs as of January, and they're accelerating. So we're seeing rapid acceleration and adoption of these ways of working, particularly the orgs in the tails of the distribution. The ones leading the charge here are really starting to pull away from the pack in their use of autonomous agents. All right, now let's talk about productivity. Even though, we're still talking largely interactive coding agents, and we're seeing some growth in autonomous agents, not necessarily agent swarms at scale. But we are seeing some strong productivity gains. So let's talk about what we're seeing. Uh, First, though, productivity can be kind of a squishy, overloaded term. There's lots of ways to attack it. So, what do we mean by productivity? Good place to start, plain old PR throughput. How many pull requests does the average engineer merge per week? Not the most exotic metric, but it's proven, it's widely accepted. One thing to note is that the absolute level of PR throughput, is two a good number. That's it's something that varies company to company. It depends on things like how you scope your work, how big a PR is for you and your tech stack. Depends on your architecture. Actually, we're going to talk about that in a little bit. But all things being equal for your org, measuring change in PR throughput for your team is a good way to track productivity gains. Another good one, cycle time. Lots of ways to define cycle time, but here we're going to talk about the time from the first commit in a pull request until that work was shipped, until it was merged. All right. So let's talk productivity. So here's what we're seeing for changes in PR throughput, and I'll explain this chart. Every data point here is a snapshot of a given company on a given week. So on the x-axis, we have a metric we call AI adoption rate. This is related to the adoption things I showed you earlier, but we've normalized by coding days. So, when engineers aren't active or on vacation, we can normalize out that behavior. So think of it as, measuring the proportion of how much engineers are using coding tools relative to the amount of time that they're writing code. So that's the x-axis. The y-axis is average PRs per engineer across that company on that week. So every week's company snapshot, average PRs per engineer. So, size independent for the company. And then the x-axis is AI adoption level. So you can see a clear correlation here. And if you fit a trend line, this average trend is about a 2x change as you go from 0% to 100%. So on average, a company should expect that as their engineers go from not using these tools to using them every time they code, that should correspond to about a doubling of PR throughput. Now, we also see some gains in cycle times, which is interesting. This is similar to the previous chart. Every point is a company snapshot on a given week. Y-axis now is median cycle time for all the work that was merged that week, and the x-axis is still level of AI usage. As an aside, I like this this distribution is kind of fun. You see these two clear horizontal bands. So, the bottom cluster is going to be all the things that have cycle times that are about one workday in length. They take less than a workday to ship. That second band above it being things that take about 2 workdays. And then you can imagine there's a big long tail of things. I've cut off the plot because there are things that take many days or even weeks to ship. But most tasks get completed within a day or two is typical. So again, there's an average trend here. It corresponds to about a 24% decrease in cycle times as you go from 0% to 100% adoption of AI coding tools. So we're definitely seeing some productivity gains. Now you might ask, what else is happening? No such thing as a free lunch. What else is going on? So one thing we've noticed is that pull requests, they're definitely getting bigger. AI is writing more code and it's writing bigger code. Here's a plot like the previous one I showed, except now the y-axis is average additions per PR. So size of the PR. And you see a trend here that corresponds to, as you get to full AI adoption, about an 18% increase in the size of PRs. If you dig in, you can look at additions and deletions. This is primarily additions is where we're seeing the new code. So we're talking about AI writing more net new code. It's not necessarily just rewriting or heavily reworking code on average. We also didn't see any changes in the number of files touched. So this change here is more about, code, the same files. AI is not finding more files to touch, but it really does seem like code that's more verbose It might have more tests or exception handling, more commenting, but it really is trending towards bigger pull requests. Now, that's an interesting side effect. I think a more pressing side effect on a lot of people's mind is quality. So, if teams are pushing more PRs and merging them faster, and if the PRs are getting bigger and maybe harder to review, you might be wondering about quality. So, there's lots of ways to look at and define quality. We'll talk about a few here, but there's many more that we're looking at. For this study, we've looked at bug tickets created and we've looked at PR reverts. So as you use more AI coding tools, is are you just generating more bugs or more bugs being reported? And are you having to roll back more code? Is more things going out the door that have to be undone because you're finding defects? And the answer is we're not seeing a ton right now. So we didn't see any statistically significant relationship with bug tickets created. We are observing some small impacts to PR reverts. We are seeing more code being rolled back. It's small, about a 7 to 11% increase in revert rates over the baseline, by which I mean all the higher adoption AI cohorts relative to little to no adoption. You're talking about on average about a 10% bump in revert rates. One interesting thing is we did see an increase in the rate of bugs resolved. So more bugs aren't being created, but more bugs are being resolved. And it turns out that this is largely because a lot of folks are pointing AI coding tools at their bug backlogs and burning those down. Things that maybe weren't high priority bugs, but things that are good, well scoped tasks to point AI coding tools and agents at. And so we are seeing some effects there. So this all adds up to there doesn't seem to be a big smoking gun on quality yet, but this is something that we're going to keep an eye on because we're starting to see some impacts. And with the acceleration of AI coding agents, autonomous agents, and with the big productivity gains and them continuing to grow, we expect that you'll start to see some pressures on other parts of the SDLC. All right. Question number 4, last question. What if your expectations don't match reality? What if you're trying to go through AI transformation in your org and you're still not getting the kinds of results that we've been talking about here? So, hopefully, I've made it clear that the most important thing to focus on first is adoption. It's obvious that you're not going to get gains unless you get folks in your org using these tools at scale. But maybe you're doing that. Maybe you're seeing high adoption. You're not seeing the kind of productivity gains that you see in your social networks. So what's going on? We've looked at a lot of things here. There's plenty more to investigate. This is a very rich area. But to wrap things up here, I'd like to share one result that I think is particularly interesting, and that's code architecture. And I'll explain what I mean by that. By code architecture, we're talking about how is the code for your products and services organized across your repositories. So you want to think like, monorepo versus polyrepo, monolith versus microservices. How distributed is your code base and how is it organized? We're going to look at a simple metric for this. Obviously, there's a lot of complexity and a lot of different models here. We're going to boil it all down to one metric, which is active repos per engineer. This is pretty straightforward. It just means how many distinct repos does a typical engineer push code to in a given week. So it's a proxy for how much of the code base does an engineer have to work with to get things done. The nice thing about this metric is, I think it's a nice way to summarize all of these different architectural and product choices. It also turns out that it's scale independent. If you compute this metric per engineer, it doesn't actually correlate with the size of the team. So as your company gets bigger, you tend to get more repos, but engineers tend to work with the same number of repos because it's more a function of how you've organized your code and not necessarily how big your company is. All right. Before we go further, let me show you a distribution of what this looks like. So this is what weekly active repositories per engineer. So how many repos an engineer worked with in a given week, what it looks like across all those companies. So this curve that you see, we've broken it up into four quartiles. So all the way on the left, if you look at this distribution, you're talking about the most centralized types of architectures. So you're talking about monorepo, single product, everything is highly, highly centralized. And then as you go to the right, you see a big long tail as things get more and more distributed. And in the orange, at the most highly distributed quartile, engineers may have to work with 4, 5, or more repos in order to do their job in a given week, and that corresponds to things like, when you want to make a single feature change that you have to push, you know, you have to work with multiple microservices or push migrations to multiple different services. So we're going to take these quartiles, these four different regions: centralized, balanced, distributed, and highly distributed, and we are going to look at what PR throughput changes look like if we slice by these four things. So, remember this chart from before. We're now going to have four of these charts where instead of every company snapshot, you're going to have company snapshots corresponding to those four different architecture regimes. And if you do that, it looks like this. So now, upper left here, we've got your centralized architectures, and then we've got balanced, and then on the bottom, left to right, distributed and highly distributed. So if you do that same analysis, we see actually big differences. So if you look at the top row, we see that the centralized and balanced code architectures, they have productivity gains that trend more like 4x, not like 2x. The distributed, the lower left, those look more like that global 2x trend. And then what's highly interested is that highly distributed case, where there's essentially no correlation. It's even slightly negative between AI adoption and PR throughput. So what's going on here? Why are teams with highly distributed architectures struggling? A big part of what you're seeing here is the problem of context. So most of today's tools are really set up to best work within one repo or one project at a time. Combining context across repos is typically challenging. It's challenging for humans as well as agents. You have to do a lot of research, hopping around, switching branches. Moreover, even if there's a lot written down in the code and it can be painful, you could do it. But there's the additional challenge that relationships between these repos and systems, the way that your code architecture is actually structured, might not even be written down clearly. It might be largely locked in the heads of senior engineers. It might be that people just know that if you make a change here, you've got to make a change over there. Your architecture diagram might be out of date. So certainly robots aren't going to have access to these things to get the context they need to make sense of this world, just like a person has to go around and use some, insider trade knowledge, drawing on, senior expertise at your org and able to get things done. So what we're seeing here ultimately is a problem of context. As an aside, another thing you might notice is that these distributions all shift upward across the board as we go from more centralized to more distributed. In other words, highly distributed teams, architectures, they just need more PRs to get the same amount of work done. And this is because of things like migrations and cross repo coordination. So this is why I mentioned earlier that counting PRs in the absolute sense isn't a great metric. You need to be tracking your own change in PR throughput to understand productivity, because this varies a lot depending on these factors. Okay, so that's it. So to recap, probably not news to anyone, but AI coding tools are being used in a big way. But autonomous agent use is accelerating fast, and we're seeing strong growth there. We're also seeing consistent productivity gains, more code being shipped. It's being shipped faster. And so, even if you're just using things like Copilot or Cursor in a code completion, maybe some agentic ways, you're using Claude Code, you should start with a 2x change in your PR throughput should be your baseline expectation. Uh, there are going to be some other things that change. For instance, bigger PRs. Quality may be an issue. There's no alarm bells yet, but that's a thing that we're all going to want to keep an eye on. And there's lots of reasons why your mileage may vary, but one place to start is to think about your own code architecture. And in general, think about context engineering. How do the humans know what they need to know in order to make sense of your code and your architecture? And how are robots going to know that to be able to do the same kind of work? And so, we see some real differences depending on the way you've chosen to structure your code. And there's going to need to be context engineering solutions to help with that. All right. That's all I've got. Again, I'm Nicholas Arcolano from Jellyfish, and thank you so much for listening.